So this is the last portion of our lecture. So we are going to talk about some of the chemical cycling and recycling. So there's chemical cycle and recycling happening in the environment. And then some key chemicals we're going to talk about is water, carbon, nitrogen. I'm not going to have time to talk about phosphorus today, so I'm probably going to skip that. So these are the key chemicals that are found in the living organisms. So that's what we're going to discuss. So all the organisms, they interact with the non-living environment. That also includes these chemicals. So that's why we're going to follow these chemical cycles and where the chemicals are coming in, where they're leaving. So those are a few that we're going to discuss here. First one is water. You can start anywhere on this cycle, but I'm gonna start here at the ocean. From the ocean, 99% of the water evaporates and then it rains back down. Once it rains back down, small amount makes its way to the land and it can end up in the lakes, or it can end up as an ice cap on mountains, and remaining runs back in the ocean. The ocean water is not very useful for us for human consumption because there's salt in it and we need to desalinate it to use it. So it's salty, it's not very useful. So that's where the water is coming. Whereas this fresh water, it's useful because it doesn't have any salt in it. So if you take all the water that's in ocean and then you take all the fresh water and you compare it to planet Earth, this is what it looks like. So here, they took all the ocean water, all of Earth's water, and they balled it up. And then look how much water is there compared to the planet Earth. And the smaller marble is the fresh water. That's the water in our lakes and the rivers. So this all, the oceans, if you think about it, they're vast. But if you compare to planet Earth, it's like a peel of skin of apple. So the water is like skin of apple around planet Earth. And if you think about the oceans, they're so deep, they're vast, and most of the oceans are unexplored by us, by humans. But when you compare to planet Earth, it's still not very much. So this kind of really puts it in perspective how small you are as a human being. So in last lecture, I talked about carrying capacity. So the carrying capacity is a limited resource. So this might be something in the future that become the carrying capacity for humans when the things get really bad. Maybe you can't find any fresh water anymore in the future. At that point, I was talking about how science always kind of finds a solution. It might find a solution, and that might be desalinating the oceans and using that water, but that's going to take lots of energy. So this is something that might cause the human population to crash in the future if we don't have enough fresh water. So that's water cycle. That's all I'm going to say about it. So producers and consumers take in water from lakes, rivers, or the ground, because that's the water that doesn't have any salt in it. Next one is carbon. Carbon is what your body is made of. Carbon is what plants take in for photosynthesis. So organisms have carbon in bodies, and when we die, the carbon goes back and it gets recycled. It goes back in the soil, compost, and then some of it goes back to the mantle and the tectonic plates, and then some of it goes back in the ocean. So I'm not going to ask you each of these steps. I'm just giving you overview of each cycle. But what should happen is that if we put a number on it, the carbon that's being absorbed by the plants for photosynthesis, that should be equaling to the amount of carbon that's being put in the environment. So there should be a balance, but it's not happening because us humans, we started using these coals. We're burning coal, we're burning fossil fuels, and we're putting a lot more carbon in the environment than that's being taken up by the plants. So what we should be doing, maybe we should be growing more plants. We should be maybe careful putting the pollution in the environment. We shouldn't be using our cars when we don't really need it, when we can walk or use a bicycle. So the carbon amount has gone really up in last few years because of our human activities. So we're causing this man-made climate change, and they're keeping record. They're monitoring this carbon amount in the environment. So they do it in Hawaii. They have this monitoring station there. The reason they do it there is because there's a lot less disturbance. Let's see if this is more recent. From other cities and countries, there's less disturbance there. It's really clear, so they can keep a record there. They can monitor it there. Okay, so this is showing from 1960s, and you see that since even before we started monitoring it, it's been going up. So it's been going up, and then you see it's going up and down in these red lines. That's because of the seasons. There are different things happening in the winter versus the summer. And then I think the number right now is around 418, 420. This is showing up to 2020. I don't know where it's at for 2021, but it's around 419, maybe 418. Now, once we hit 450, there's no coming back from that. So there are still some things we can do now, but I think once we hit the number 450, there's no turning back from that. So we still have a chance to do something about it. So I always encourage my students to maybe think about the environment and use your car less, only use it when you really need it. So try to maybe reduce the pollution in the environment. And this carbon is also having impact on the greenhouses. So greenhouse gases. So what's happening? So carbon dioxide in the environment is trapping heat that's coming in. So otherwise the heat hits the ocean, the sun rays, they hit the ocean and they bounce back. But because all this carbon is in the environment, now it's hitting the ocean and it's hitting the greenhouse gas carbon and methane. Methane, we talked about that too. So these gases are trapping heat, which is warming up our planet. So because of COVID now, there was less driving. I think it might have had a little bit effect on the greenhouse gases or the carbon in the environment, but all this is causing the planet to warm up. Another thing, I already showed you that some of the carbon is going back in the ocean. So CO2 is dissolved in ocean. That's causing ocean acidification. So what happens when this carbon goes in the ocean? When it combines with water, it makes carbonic acid and turns into carbonic acid. And the implications of that are that if there's a lot of carbon dioxide that's going into the ocean, it's going to make lots of carbonic acid, which is going to cause the oceans to be acidic. So it's going to cause the oceans to be acidic. And what the acid can do, if you want to do an experiment, you should take Diet Coke and put a tooth in it, or something that has calcium. So it's gonna decay. So this is showing time spent in soda. So there's the ocean acidification. It's causing the shells of sea creatures to thin out. So they've been studying this for maybe 10-15 years now. They have evidence for it. It's causing the shells to be thin because they're made out of calcium, and it's also causing some behavior changes in these mollusks or other species, where the fish were supposed to swim away from the predator, now is swimming towards the predator, and they have evidence for all that. So the carbon dioxide is giving two issues. One is warming everything up, so warming up the planet because it's trapping heat. Second is causing the oceans to become acidic. I think this is very important for students to learn. If it were up to me, I would probably make this one of the learning outcomes for students. So this is really important that you guys know about it, because it kind of, tells you what we're doing to the environment. So I will ask you about ocean acidification on the exam, because it's a very important topic. So that's carbon cycle. So photosynthesis removes carbon from air. Autotrophs use carbon to make organic molecules such as sugar, but because there's no balance, we have a lot more carbon in the environment than the plants are being, what the plants are observing. Next one is nitrogen. So nitrogen makes up proteins. It's this CCN, carbon nitrogen. It makes up proteins in your body. Amino acids are made up of these molecules. And the nitrogen that's in our body, it's coming from plants. We are breathing about 80% of nitrogen gas that's not usable by plants. But there's bacteria in the ground that's called nitrifying bacteria and archaea species. They're fixing this nitrogen. So the nitrogen is otherwise to be locked up in the environment in a form that's not very useful. So this bacteria is breaking down this nitrogen gas, and it's turning it into ammonia or nitrite, which can be used by the plants. So plants are taking up this nitrogen from the soil that's been fixed by this bacteria. And that's also something that's found in plant fertilizers. There's nitrogen that's in there. And then animals or us, we eat the plants, and that's how we get the nitrogen that's useful. So bacteria is very essential for making the nitrogen useful. And then the living organisms get the nitrogen from these plants. Some of the factories, they also produce nitrogen, but this is more of a pollution. So it creates pollution. So all of these things, they interconnect. So here it's saying that nitrogen is component of proteins and nucleic acid. It's abundant gas, but the organism cannot use this form of nitrogen. Therefore, it has to go through nitrogen fixation, and then we can use it. The one that's coming from the factories is creating pollution. And the process is called nitrogen fixation. They can convert nitrogen gas into ammonia, which is taken up by the plants. And that's also something that's found in the fertilizers. So all these things, they interconnect. So another thing I want to mention here is showing tomato plants that's doing photosynthesis, getting eaten by the consumers. And then consumers, once they die, they decompose, such as bacteria, breaks their bodies down and goes back to the environment. So those are biotic factors. And then we have abiotic, those are chemical cycles that are in the soil that are being taken up by these producers. So all these things, they interconnect. And then I think it's very important for you guys to kind of understand this, because then you can pass on this knowledge to your kids, maybe to next generation. And it's really, really important because it can impact our ecosystem or the food webs. So you guys use this knowledge basically in everyday life. If you like maybe gardening, you can start using the fertilizers that have nitrogen in it. You will know what fertilizer to buy. If you're talking about maybe buying groceries from a store, maybe you buy some tomatoes, and you will notice that grocery store tomatoes, they have no flavor. And the reason for that is because they harvest them when they're still green and there's no flavor in them, versus maybe when you buy canned potatoes, they're going to have more flavor because they harvest them when they were red. So if you grow your own tomatoes or you buy it from farmers market tomatoes, it's going to be big difference versus the grocery store tomatoes, because there is no flavor in them. And then that's sometimes that's the reason that people don't even eat tomatoes, because it has no flavor. So all these chemical cycles, they're similar. And then there is cycling and recycling happening. And there is a connection between abiotic reservoirs and then the biotic reservoirs, where the consumers and autotrophs and decomposers, they are impacting each other. And then it's also related to the chemical cycles. So understanding nutrient cycle is really important because it's connecting different organisms together, and then the abiotic reservoirs as well. And I think that's it. That's end of the lecture.